I'm slowly going down the list. Kind of tired of significance has homework, so I'm gonna go ahead and do homework number 13, number 27, and this may be the last one, and I'll come back and keep on doing this. I may be able to get a lot done probably on Friday. All right, homework number 13, number 27. Let me go over there. This is a brand new one that just opened up today, right? Where did you go? Oh crap, what number was it? 27. Okay, Anna's project for her introductory statistics course was to compare the selling prices of textbooks at 2 internet bookstores. She first took a random sample of 10 textbooks and used that term in courses at her college based on the list of texts compiled by the college bookstore. On the list, the prices of those textbooks at the 2 internet sites are shown below. Complete A through C. Okay. Oh, I like this button. I like to just send that data to StatCrunch. Or I did it, but now where's my homework? Where did my homework go? Oh, this right here. No. Oh, gee. Here it is. Let me minimize this so that I can open both screens. So what are we doing? Are these independent samples or dependent samples? Just justify your answer. Choose the correct answer below. Now listen, this is what's happening. So she has a list of 10 different textbooks, right? 10 different textbooks. And what she's doing is she's comparing the price of, the same textbook on site A and site B. In my example, we use Amazon and textbook.com. But when I look at the price, the first one, $115 and $110. So one side is selling it for $115, the other side is selling it for $110. Okay? But now these two prices are coming out of the same textbook, right? Someone's just selling it cheaper. So it doesn't make sense for me to compare the $41 textbook to a $96 textbook because they're two different textbooks. They're going to be different in prices, right? But it makes sense. I mean, what we are doing is we're taking two measures for the same textbook. So these are going to be considered dependent samples. Why? Because we're looking at the same textbook's price on one website and the same textbook's price on another website. So if a book is going to be $1,000 on website A, it's probably going to be very expensive on site B. It's not going to be like $20 compared to $1,000. So the price of a textbook in one website is going to somewhat be similar to the site the price in another website. So this is going to be dependent samples because the same books are used for each sample, right? And what we're going to do is we're going to compare who's cheaper, who's selling it for cheaper. Let's see. I want to do a test. Find the mean for each sample. Find the mean for different scores, where the difference is the price at site A minus price at site B. Compare and interpret. So they want you to find the average textbook price on site A. Let me do that. And you know what? While I'm on it, let me go ahead and find the average for site B too. So take a look. We do stat, summary, stat, and columns, right? Summary, stat, and columns. Click on both site A and site B at the same time. I'm holding down my command button. I want the mean for both of them. So what I got is this output table right here. And let me go ahead and bring up my homework so that I can type these answers in. Who's cheaper? Who's selling it for a little bit cheaper? I mean, overall, all different textbooks. Site B has cheaper average, right? $82.10 compared to $86.20. So by just looking at that, I would say site B must be cheaper in general. But I mean, if you look at individual, some books are cheaper on site A. Is it? Oh my gosh, not really. Not really, I don't think. I don't see any books that are cheaper on site A. I think site A is just expensive. But is that statistically significant enough so that we should definitely shop at site B? Well, let's take a look. So the X bar for the first sample is 86 point. What's that? Oh gosh, 86.2. and hit enter. And the mean for the site B is 82.1. And check answer. Okay, so we found the mean. Now, what about their difference? What about their difference? Now, we can find this by just subtracting these two numbers. Or technically, I mean, we should be able to. I wonder if it works as Excel. Maybe I can type in a formula. I can do site. I don't think it's gonna work as Excel, but what I showed in class is this. I actually showed you to do the t-stat paired, and then we can set the sample 1 is inside A, sample 2 is inside B, and then click on the difference to kind of just see the difference. And then if you just click on any of it, doesn't matter, hypothesis, test, or confidence interval, what they will do for you is they will find that average difference. Now, the average difference, they said mean over here, right? But mean of what? Mean of difference between site A and site B is $4.10. And what they did is this. They subtracted $115 minus $110. That's $5 difference. $79 minus $79. That's a $0 difference. So what they did was they took the difference, they took the average of this difference column. Okay, and I can do that real quick by doing the summary stat. What is the mean of this difference column? And that's going to be 4.1. Okay, now you can do it this way and you can do it that way, but I'm gonna show you something cool though. Okay, so if I go back to my homework page, the difference, average difference, or they call the mean of the difference score is 4.1. And I think the next question, I remember this because we did something similar to this on during our class today. Compare and interpret. Now take, they really didn't. Maybe I'm looking at a different question. Now, but take a look. We can find that 4.1 by just simply subtracting 86.2, right? Minus 86.2 minus 82.1 equals 4.1. So you can do it that way. You don't have to do some kind of fancy statistics on StatCrunch. You can just subtract the average of group 1 minus the average of group 2, and you still can get the mean of the different scores there. All right. Let's see. Compare and interpret. Choose the correct answer below. What are we doing? The mean for site A is less than. That's not true. The mean was higher. $86 is higher than 82. So I'm looking for something that says mean of site A is greater than the mean of site B. Okay. Thus, the mean of the different score is positive. Yes, because we subtracted it as site A minus site B. If you subtract big thing minus small thing, the difference will come out to be positive. The mean book price at site B is less than at site A. I like that one. Okay. Remember, depending on how you subtract, you sometimes get a positive answer, sometimes you get a negative answer if you subtract big thing from small things. All right, what's next? What's that circle going around for? Last part over here. Using software's calculator, construct a 90% confidence interval comparing the population mean prices of all textbooks use that term at our college. Price at site A minus price at site B. We know how to do this. Now take a look. I'm going to close all these real quick. I don't need this. They want you to do a confidence interval, right? Go to stat, and this is, we're looking at average, right? Whenever you're estimating or conducting a hypothesis test about population average, then we're gonna do t-stat, because we don't know the population standard deviation. So t-stat, click on paired. Why is it paired? Because these are dependent samples. Whenever you're working with dependent samples, you want to you want to do paired t-test. But I think they wanted confidence interval. So set your sample 1 as site A, set your sample 2 is in site B, and click on confidence interval, and I think the level they wanted was 0.90, 90%. So I changed it to that, and I compute it, and there we have it. Here is my confidence interval. I'm going to go ahead and type that answer in here. So they got 3 blanks. What are we doing here? Oh, we have to read and see which one is the best. Now, let's take a look at this limits here. Lower limit is 1.32. Upper limit is 6.8. What we talked about is this in class. what's the number that we want to see or we don't want to see? Or we should say, what's the number that we care about? Like, remember, like, if they are the same, there's no difference, right? See if that makes sense. If they are the same, there is no difference. That means, I mean, if you subtract two same things, subtract 10 minus 10, 9 minus 9, 7 minus 7. If you subtract the same thing, you get 0, right? So if you have 0, if you get 0, that means they are the same. They're not different. So whenever you create these confidence interval to estimate the difference between population average, you want to see if 0 is included in your confidence interval. Is 0 included in between 1.3 and 6.8? No, it's not, right? This interval is completely positive. It's above 0. The fact that it doesn't include 0 is telling us that they're not the same. They are different. Because if they are the same, if they're not that different, then we would have seen 0 included in that interval. So what we're gonna say is, where did my homework go? It is plausible that the mean price difference is A is wrong and C is also wrong. It is not plausible that the population mean price is 0 because 0 does not lie in the confidence interval. When I created this confidence interval, guys, 0 is not in it. 0 is the left side of my lower limit. So if 0 is not in this confidence interval, that means the price is definitely different. It's definitely different. So let me go ahead and give them the confidence interval right here, 1.32, and then the other one, they wanted you to round to the 3 decimal places, 6.8. Crap, it's 6.879. All right, I rounded it. And then check answer. So that's how you would do it. Whenever you create your confidence interval, you want to make sure, check and see if 0 is in your interval. If 0 is in the interval, that means there's no difference. They're probably the same, or you can't tell that they are actually different. But if your confidence interval is completely above or completely below 0, both the lower limit and the upper limit is positive, or both the lower limit and the upper limit is negative. If that's the case, then we can say, oh, they are different. Because when you subtract two things and you get a positive number or a negative number, that means one thing is bigger than the other. Okay? So that must be it. That must be it. You guys didn't ask me any questions on homework number 13 other than this one yet. So I am done with homework number 13 review. But of course, email me if you find anything else. But I'm going to have to come back later to finish up homework number 12 questions. I felt like I did assign some mean homework on homework number 12. But I'm going to go ahead and definitely go over them and then post the videos as I do them, okay?